Welcome to an introductory to factoring. Think of factoring like doing distributed property but backwards. Remember distributed property. If I had 2 and then in parentheses I had x plus 3, how would I simplify this? I would take the 2, multiply it by x to get 2x, and take the 2 times the 3 to get plus 6, and then this would be my answer. Well, if you look at number 1, we start with what is the answer, and we want to bring it back to something that looks like this. The easiest way to do this is to start with the whole numbers. I have the numbers 40 and I have the numbers 90. So I am going to list all the factors of 40, looking for the greatest common factor between 40 and 90. Well, there's 1 in 40, 2 in 20, 3 is not a factor, but 4 and 10 are. 5 is a factor. 5 times what gives me 40? 5 times 8. 6 is not a factor. 7 is not a factor. And now I'm right back to 8. Now, how could I do this if I didn't know my factors? I could take the number 40 and divide it by each of these numbers to see what the counter number is. And then when I got down to here and I tried 6, and it didn't give me an answer, and then I tried 7 and it gave me a decimal, I would know I was done because I was rounding right back to the 8. And now I'm going to make a factor tree with 90. I have 1 and 90. I have 2 and 45. I have 3 and 30. You'll notice as this side gets bigger, this side gets smaller. Is 4 a factor of 90? No. Is 5? Yes. 5 times 18. Is 6 a factor? Yes. 6 times 15. Is 7 a factor? No. Is 8? No. Is 9? Yes, 9 times 10. So once I create both my factor lists, I'm going to go through and find the biggest common factor. Do they have 90 in common? No. Do they have 45 in common? No. So my next biggest number is over here on the 40 list. Is 40 in common? No. Is 30 in common? No. Is 20 in common? No. 18, 15, here it is with 10. I have 10 in this list and I have a 10 in this list. So I know my greatest common factor must be the number 10. So I can divide out of each of those numbers the number 10 and still end up with a whole number. 40 divided by 10 leaves me with 4. 90 divided by 10 leaves me with 9. Now I look to the variables. What is the biggest number of variables I can take out of both? Well, this one has 2 x's, and this one has 1. So I can remove out 1 x, so I'm going to remove that x out, and leave the 9 with no variable. And I can take out 1 x here, and leave an x there. So my answer is 10x times a quantity of 4x plus 9. If I wanted to check my answer, I could distribute a property. 4 times 10 is 40. X times x gives me x squared. 10x times 9, 10 times 9 is 90. Did I come up with my original problem? I did. Therefore, I know I did it correct. You don't have to go through and check them, but if you're curious whether or not you're correct, it is the easiest way to determine. Let's try number 2. Again, I begin with drawing my parentheses, and I begin with, okay, I have factors of 16 and factors of 14. So I have 1 and 16, 2 and 8, 3 is not, but 4 times 4 is, and I'm already back up to these 2 match, so I know there aren't any more. Then I'm going to go to 14. 1 and 14, 2 and 7. Are there any others? No. So which is the biggest one they have in common? That would be right here with 2. So I know I can divide 2 out of both of them. Also, because they're both negative, I can make that a -2, which then turns them both positive. 16 divided by 2 gives me an 8. 14 divided by 2 gives me a 7. Then I'm going to look to my letters. I have n squared and n to the third. So what is the smallest one? They each have 2 n's in common, so I can take out 2 n's. If I take 2 n's out of n to the third, I'm left with 1. If I take 2 n's out of n squared, I'm left with none. And so my answer looks like this. Again, if I wanted to make sure I was correct, I could always go back through and distribute a property and make sure I ended up with my original problem. We are now going to flip to number 7, 8, and 9 so that we can do some 3-term problems. I do the exact same steps. I begin with the numbers. I have the number 15, I have the number 24, and then I have another number 15, which factors will be the same as the first 15. So let's go through. 1 and 15, yes, 1 is always a factor. It's not even, so 2 is not a factor, but 3 times 5 will give me 15. 4 doesn't work, and so I'm done. Look to 1 and 24 now. 1 times 24, 2 times 12, 3 times 8, 4 times 6. What's the biggest number they both have in common? Right here at this 3. So I'm going to take a 3 out of each of them. So 15 divided by 3 gives me a 5. Negative 24 divided by 3 gives me a -8. And my last 15 divided by 3 gives me a +5. Now I'm going to look to the variables. What is the smallest exponent you see? I see a 6, I see a 4, and I see a 2. So I could take 2 out of this 4, out of this 6, and out of that 2. And that's what I'm going to do. If I took 2 away from that 6, I would have x to the 4th left. If I took 2 away from that 4, I would have x squared left. And if I took 2 away from x squared, I have nothing left, and so I'm done. And that is my answer. On number 8, you'll notice your middle term does not have a big number. Since it does not have a big number, you cannot factor out a coefficient. So I already know my 3 here will stay, and my +5 over here is going to stay. Let's see if I can factor out a letter. Well, my first term has a letter. It has p to the 4th. My second term has p to the 3rd. And my last term has p squared. So what is the smallest number of p's my terms have? Right here with p squared. So I'm going to take p squared out of each of them. If I took 2 p's away from p to the 4th, I would have p squared left. If I took 2 p's away from p to the 3rd, I'd have just 1 p. If I took 2 p's away from p squared, I'd have none. So my answer ends up with 3p squared plus p plus 5 with no p on the end. Number 9 puts you right back with numbers. So I have a 16, I have a 32, and I have a 40, and I'm looking for the greatest common factor. Again, I'm hoping you know your multiplication tables enough that you don't have to go through this every time. But even if you do, it's still good practice. We've already done 16 once, so I wrote those down. Now let's do 32. 1 times 32, 2 times 16, Is 3 a factor? No, 3 is not a factor. 4 times 8 is, though. Is 5 a factor? No. Is 6 a factor? No. 7? No. And then I'm right back at 8, and 8 times 4 is 32, and I already have that written down, so I'm done. Let's look at 40. 1 times 40. 2 times 20. 3 a factor? No. But 4 times 10 is. What about 5? 5 times 8? What about 6? No. What about 7? No. So what number do all 3 of them have in common? Well, they don't all have 40 or 32. But these two have 16. Does the third one have 16? No. So it can't be 16. Those two don't have 20. Those two don't have 10. But look, here's an 8. Here's an 8. Here's an 8. So I can take an 8 out of every single one of them, and that's what I'm going to do. Now, do they all have a letter attached to them? This one does, and then there's no letter. So since there's no letter on that third term, I cannot factor out a letter. So I won't. So now all I have to do is divide. I take negative 16 divided by my 8 that I'm taking out, so I end up with negative 2, and since I don't have a letter attached to that third term, the x squared stays. Now I'm going to take my middle term, negative 32 divided by 8, leaves me with negative 4x, and now my last term, 40 divided by 8 is a positive 5. I want you to attempt the remainder on this front side. If you get done with the front, feel free to flip it over and do the back. Let me know if you have any questions. I'll be back on Thursday to clear things up a bit.